Let's start today's topic: static indeterminacy, degree of redundant and hyperstatic structure, which is nothing but extra. What is this extra force in a structure that we are determined here? These are, we discuss a lot of problems in previous lecture. This S is equal to 2, R is equal to 3. Okay. Next, here this example, R is equal to 3, R is equal to 3, which are the horizontal, vertical and moment equilibrium equation. Next, statically determinate structure. What is statically determinate structure? If the number of unknown forces of a given structure is equal to the number of equilibrium equation is known as statically determinate structure. What are the example? Simply supported beam. Oh yes, S is equal to R. Number of equation is equal to number of equilibrium. Cantilever beam, 3 hinged arch and double overhanging beam. These are the examples. Next, statically indeterminate structure. If the number of unknown forces of a given structure is more than number of equilibrium equation is known as statically indeterminate structure. It is nothing but R is greater than S. Okay. Example: proper cantilever beam, fixed beam, continuous beam and 2 hinge arch, etc. Next, yes, static indeterminacy, whose formula is ds is equal to dse plus dsi. First of all, we discuss dse. Okay, dse. dse stands for external indeterminacy. If ds is equal to 0, it is statically determinate structure. Okay. If ds is greater than 0, then it is statically indeterminate structure. If ds is less than 0, it is ds is less than 0 is equal to unstable mechanism. Here there are two types: external indeterminacy and internal indeterminacy. First of all, we discuss external indeterminacy, which is DSE. Okay. Yes, DSE plus DSI plus, okay. DSI we discuss later. Okay. DSI external. It deals with support reaction. Okay. Support reaction means here is not support. This is one support, is another support. Okay. Next, it is same like this. ds is equal to 0, is indeterminate, greater than 0, indeterminate, less than 0, externally unstable. Yes. Here, externally and internally, we discuss 3 cases: one beam, rigid joint and bend joint. Okay. Number 1, beam. For beam, let's consider one example: fixed support, hinge support. Okay, whose formula is dsc is equal to r minus s. Okay, r minus s. R is number of reaction, s is equilibrium condition. Yes. Okay, r is equal to 5 for this 1, 2, and moment 3, and for this 1, 2. 5 is equal to 3 for beam when there is general load HVM. Okay, this is equal to 5 minus 3 is equal to 2. If value is greater than 0, then it is externally indeterminate structure. Okay. Next, another example. When there is a beam and we apply pure load on a beam, then we can't consider horizontal reaction explained in previous lecture. Okay, these are reaction is equal to 0. It is externally determinate structure if ds value is equal to 0. Then next, case 2 for rigid jointed plane frame. Okay, we know formula is ds is equal to r minus s and s is equal to 3 for rigid joint, which are the fx, fy and mg. Okay, formula ds is equal to r minus s. Consider one example. Fixed support 3 reaction, then r is equal to 6. Okay, 3 3 6 and s is equal to 3. We know that. Yes, r minus 6 minus 3 is equal to 3. Hence externally indeterminate structure for a rigid joint. Let's consider one standard example. Okay, for horizontal guided roller, reactions 2, fixed support 3, hinge support 2, roller support 1, horizontal roller support 2 and axial and vertical 2. Count the reaction. Here r is equal to 13 and s is equal to 3. Yes, 13 minus 3 is equal to 10. Externally indeterminate structure. Next, case 3, pin jointed plane frame. Yes, pin jointed plane frame. For pin jointed plane frame, s is equal to 3. Okay, let's consider one example. Reaction 2 for hinge support, 1 for roller support, 1 for roller support, and is 4. Yes, and s is equal to 3. ds is equal to r minus s. 4 minus 3 is equal to 1. Externally indeterminate structure. Yes, let's discuss what we call as truss, because truss is important character in pin jointed. Okay, let's discuss condition for truss for pin jointed. Okay, all joint are pin joint connection including support and hinge. Okay, all joints are pin jointed like this. All joints should be pin jointed. Okay, next, member should be straight. Member should be straight. Straight ही होना चाहिए. Okay, not like this. If like this structure is like this, then it is not considered truss. Okay, they will bend and structure cannot called as truss. Okay, next, load acts only at the joint. Load should act at joint only, not on the member. This is not correct. Load should act at joint. Okay, yes, that's it. Then we call it as truss. Yes, bend, not bend. Next, that's it for this lecture, because in next chapter we discuss internal indeterminacy. If we discuss here, this video is got too lengthy. If you have any doubt, please ask me in the comment section, and like the video if you like the video. Okay, and subscribe to our channel Civil Engineering Guides. Thanks.